SQL+ and iSQL+. I'm going to show you in this nugget how to use SQL+ to tap into your database. Now, you're probably wondering, come on, isn't this a DBA course? Aren't we going to do some complex things? Well, we need to start somewhere. You need to have a user interface, and you need to be proficient in it if you're going to be an efficient DBA. Now, the reason why we use SQL+ instead of other graphical tools out there is that it comes bundled with every version of Oracle. And oftentimes as a DBA, you're only going to have access to some remote databases out there without any GUI interface at all. So first we're going to connect to our database. I'll show you some really neat editor shortcuts. We'll do some spooling to some files, so save the evidence. And then we'll configure our environment as well as create and run dynamic scripts. And then the very last thing I'll show you in this nugget is how to use iSQL+, which is just a browser-based version of SQL+. It's a really neat tool. So let's get started. So let's log into SQL+. SQL+ is an executable file. We can get to that by going to our command prompt and typing in SQL+. That is under the Oracle Home bin directory, but really you can launch it from anywhere since that executable should be in your path environment variable. I'll show you that in just a moment. So we hit SQL+. It prompts us for the username. I'm going to type in Scott. Scott is one of those built-in usernames that you can turn on when you install Oracle. And by default, the password for Scott is Tiger. So when I type that in, it doesn't show up on the screen, but I am typing it in. Okay, so it looks like we're in. Now you can have several databases installed on the same machine. So when we typed in SQL+, how did it know which database to connect to? Well, it knows by an environment variable called Oracle SID. In fact, I'm going to go back to the operating system prompt. We type in host to get there, and I'm going to echo Oracle_SID. If you're in Unix or Linux, you would put a $sign in front of the Oracle SID and make sure that all those letters are uppercase. Okay, so it looks like our SID is ORCL. If I had a second database on this machine, then it would have a different SID. It's just a unique identifier. Okay, good. So to get back to our prompt, our SQL+ prompt, we can hit exit, and there we go. Now, what if you're managing hundreds of databases and you forget who you're logged in as, or you forget what SID you're logged in into? Well, you can just type in define, and it will display some predefined variables here. For example, the connect identifier is ORCL, that's our SID. The _user, that's Scott. And some of these others, we will eventually cover all of these, but the _date obviously is the current date, and so on. So looks good. How about if you want to log in as a different user and you're already in SQL+? Well, you don't have to exit SQL+ and relaunch it. What you can do is type in connect and then the username and the password. So we can say connect sys as sysdba. Now, sys is a username. Sysdba is a special privilege. It gives you root-like privileges so you can do anything to the database. So whenever we say a username as sysdba or as sysopper, it means that we're using this special privilege. And I'll show you in a later nugget how to define who gets to implement these actual privileges. Okay, so it prompts us for our password, and I go ahead and type it in. Okay, now we're going to type in define and see how it now tells us that we're sys as sysdba. I want to show you one more way of logging in. Earlier when we logged in as Scott, we just said SQL+ Scott and then hit enter, and then it prompted us for the password. We can actually give the password on the same line. For example, we can say connect Scott/Tiger. Now, you can do this, but it's not a recommended method, and the reason why is for security. On some Unix and Linux systems, if you type in the password on the same line as the username, then when you are when you're executing the PS command to show all your processes, sometimes that password will show up, and that's a pretty big security breach. So try not to do this. And then to exit out of here, we can just type in quit. And we're back at our prompt. Every table in the database belongs to a particular schema, and that schema will match up with somebody's username. So what we're looking at right now is scott.emp. So we've got the Scott schema, the emp table space, and here's the structure of our table. Looks like we've got several columns. We have the emp number, e-name, job, manager, hire date, salary, commission, and department number. Now, if I'm logged in as Scott, I don't have to fully qualify scott.emp. I can just say emp. Okay, if I'm logged in as somebody else, then of course I'll have to say, select star from scott.emp. I'll have to fully qualify it. Now, each of these columns has a particular data type attached to it. For example, the data type might be a number, which can be either integers or floating point numbers. For example, if you have number with 3 in parentheses, that means it has to be an integer up to 3 digits. Or you might have something like this, number 2, 2. That means a precision and a scale of 2. In other words, a value like 0.23 would be a valid value for that data type. As far as characters are concerned, if you're dealing with varchar2, that's a data type that's dealing with variable characters. In other words, if we have varchar2 with the 10 in parentheses, it means we can store up to 10 characters. Okay, so if you have the last name of Smith in there, really only 5 characters are going to be stored. 5 bytes will be stored. So that's what makes it variable. There's another character data type called char, and if you have a data type that looks like that, even if your last name is something short, it will still store 10 characters. So it's not as efficient as varchar2. Another data type we've got is date. Okay, date's pretty straightforward. It stores the year, day, month, hour, and minute, and seconds. It does not store milliseconds. We do have another data type called timestamp, which stores the milliseconds in addition to all the other information. So those are our basic data types. There are some more complex data types that we're not going to get into full detail in this course, but you might hear of what we call LOBs. That stands for large object. So for example, if you've got a binary large object, we call it a blob. If you have a character large object, that's a clob, and so on. So we will touch on this a little bit more later, but not in depth. So we're logged in as Scott, and we want to find out which table Scott owns. So we'll say select table name from user tables, and what do we get? We get 4 tables. Now, if we want to hone in on one of these tables and look at all the particulars, we can do a describe, or DESC for short, describe emp. So here we have 8 columns in this table, and it shows us the data types, and this not null simply means that whatever data we enter, the emp number must always be populated. Let's run a query for Scott. Okay, we're going to grab the emp number, e-name, job, hire date, and salary from emp, order by 2. 2 is the e-name. Okay, second column in that select clause. A couple things for you to notice. In our query, we have a number 2 and number 3. Those are just line numbers to help us keep track of where we are in the query. And by default, the headings are going to be displayed for every page. So it looks like the default page setting here is set to 12. So 12 rows. Every 12 rows we're going to get a heading. We can reset that to something else by saying set page size and then whatever that size is, so 200. Now if I want to re-execute what's in my buffer, I just hit a / and see how the formatting is a little bit different. We only get one heading. Now at any given point, there's going to be only one query in your buffer. Your buffer can only hold one statement. If you want to see what's in that buffer, just type in L, or you can type in list. The star next to the 3 just means that 3 is the current line number. We can set that to something else by simply typing in the line number. For example, we can type in 1. Now there's a star next to it. If we want to change emp number to department number, it's simple. The C stands for change. Then we have a / and the text that we're going to replace, and then the text that we're going to replace it with. Okay, we hit enter, and now this is what our new line number 1 looks like. If you want to see the whole statement, just type in L. or list. Okay, so that's what's in our buffer. Remember, to re-execute what's in the buffer, you can simply type in a /. We've already issued a combination of SQL statements and SQL Plus statements, and I want to clarify to you what the difference between these two things is. First of all, SQL stands for Structured Query Language. It's used by a lot of different relational database systems, not only Oracle, but also Microsoft SQL Server, Postgres, MySQL, and so on. And so all of these different types of database systems use this technology called SQL to extract information from the database. So a lot of times people will call Microsoft SQL Server simply SQL, and that's actually not 100% accurate. Okay, it's SQL Server, so please don't mix up the two. SQL Plus is an Oracle-specific tool to let you tap into the database. Think of it as the interface. You need to have some kind of program that lets you get into the database. Now, SQL Plus is not the only tool out there, but it does automatically come bundled with the Oracle download. So what you're seeing on the left-hand side here in red are examples of SQL statements. Select * from emp. That would grab all of the rows in our emp table. Our second example, delete from emp where job equals manager. That would delete every row in our table where the job is equal to manager. We also have examples of insert statements. Here we're just inserting a row. Joe Schmo, his employee number is 9999 and he's a sales rep. Commit, that just means to save the data that you've already manipulated. Rollback is the opposite of commit. It says undo all of the information since the last commit or rollback. Okay, so now on to SQL Plus commands. Notice that none of these commands have a semicolon at the end. If you were to put a semicolon there, it wouldn't hurt anything. It's just not required. So any of your set commands or any of your column formatting commands are all SQL Plus. Well, why do we make a distinction between SQL and SQL Plus? Well, the big reason here is because when we're dealing with our buffer, which we'll talk about in just a moment, you'll see the difference. When you issue a SQL statement, whatever your last SQL statement is, that will get saved in the buffer. Your SQL Plus statements do not get saved in the buffer. So you see here that there's lots of SQL Plus statements that help you format your output. Now keep in mind that this formatting is only good for the session. In other words, if I issue this set line size statement, it's only good until I set it to something else within the session. If I exit out and then get back into SQL Plus, it's forgotten everything. Now if I put these SQL Plus statements inside of a script, then they stick with that script. Now we've got 14 rows of output. Looks like Smith here was hired in December of 1980. We're assuming 1980. How do we know it's not 2080? Well, by issuing an alter session set NLS date format to a different format, we can change that. So it looks like our session has been altered. Now we can re-execute what's in there. Select department number, and so on. And see how our date looks a little better? So yes, indeed, this person was hired in 1980. Boy, I think I was wearing purple leg warmers that year. I must have been in 6th grade. Oh, I just dated myself. Okay, let's take a look at the salary. Do we like this salary? Well, I hope this is monthly and not yearly. Let's format it. A SQL Plus statement to format a column is like this. You say column, or just COL for short, then the column name, format, and here we're putting a $sign and we're putting commas every 3 digits. The .00 means to display those numbers no matter what after the decimal point. Okay, so we go ahead and re-execute our statement by issuing /. There we go. Looks a little bit better. Describe, column, set, those are all SQL Plus statements. They're not saved in the buffer. That's why we could hit a / and it would re-execute our statement. Now, the alter session statement, that was actually a SQL statement and that was put in our buffer. Now let's change our heading. Our e-name heading up here, I don't like that. Let's change it to say employee name. Since I want those two words to appear on different lines, I'll separate them by the pipe character. So now re-execute it. Looks a little bit better. We can do the same thing with our salary. We can say column, sal, heading, salary. By default, your headings will have these little dashes. You can change that to something else with the set command. Here we're changing the dash to an equal sign. That looks a little bit different. Let's add another column to our query. So here's our query, and I want to tack something on to the end of line 1. So the way we do that is we first make line number 1 be our current line. Now we can use the append statement or just A for short. Make sure you do 2 spaces after the A, and then you specify what you want to tack on. Okay, so here we'll do a comma, and let's also list the commission. Okay. Now those 2 spaces are only necessary if you want the first character that you're adding to be a space. I'm just showing you how to do that. Never put in quotes because the quotes will automatically go in the query. So we re-execute it, and some of our employees have commissions. Our commission column is also a monetary data type, so wouldn't it be nice to have the formatting look like the salary formatting? Well, one shortcut for doing that is to say col, com, like, sal. Now it's also a good idea to specify what the heading is going to look like, otherwise it will have the same heading as the salary. Not a good idea. So here we'll say heading commission. Now we go ahead and re-execute that. That looks great. Let's also make the job column be a little bit wider, so we can say call job format, and let's say A15. Great. How about undoing any of your formatting for the columns? You do that with the clear command. For example, if I want to clear the commission formatting, I say call com clear. If I want to clear it for all of the columns, I'll say clear columns. Now this is not going to affect the hire date because remember, hire date is a data type, and that can only be manipulated by NLS date format, altering the session like I showed you earlier. Okay, so looks good. Keep in mind that your buffer is only going to save the last SQL statement that you executed. So you can imagine how frustrating it can be if you have this really long SQL statement and then you issue this other SQL statement, then your original one is gone. Unless, of course, you save the SQL statement to a file. And the way we do that is with the save command. So here's what's in our buffer. We can simply say save, and then we specify our own file name with the .SQL extension. So we'll call this allemp.sql. Okay, so now, where is this file going to be saved? It will be saved in the directory from where we launched SQL+. If you want to save it to a different directory, that's fine. Just put the full path. How about executing your statement or executing whatever is in your file? You can say @allemp. Let me show you one more example. Let's change up our query. So instead of saying order by to for line 3, we're going to say where job equals president. Okay, so this is what our query looks like. We can save this, and we'll give a full path this time. We'll put it in the temp directory and call it president.sql. Okay, so let's execute the president. Okay, that didn't sound really good, but you know what I mean. Okay, so the way we execute that is C:\temp president. We do not have to put the .SQL extension. There we go. As a DBA, you're going to use this a lot. I have hundreds of DBA scripts that help me along to find things like table spaces that need to be shrunk down, things like that. So far, all of our output has just been splashed to the screen. I'd like to keep a hard copy of all the stuff that's been going on, so we can issue the spool statement to do that. It's kind of like the T command in Unix and Linux, where it goes both to the screen and to a file. So if I say spool output.txt, and then I issue some statements, for example, execute what's in my buffer, do all sorts of things like that, I can issue as many statements as I want to, and then when I'm finished with my spooling, I say spool off. So what I've done here is all this output has gone to a file called output.